Today, we are going to start off by talking about symmetry. Okay, we did symmetry the first day of school. Remember when we did the letters, the A, B, and we kind of put them all in different groups? We're doing something similar today, not exactly the same. We're going to introduce some new vocabulary. Okay, we can describe something as an even function. When you think of something as being even, okay, not in the number sense, but just like in the symmetry sense, what do you think if something is even? What could you do with it? Fold it. Right? It's balanced. You've got a little bit on both sides of the graph. So to me, when we are even, that is y-axis symmetry. If say you have an even function, that is y-axis symmetry. It is balanced on your graph. You can fold it right over that line. Okay, so if you have an even function, y-axis symmetry. Okay, if you have an odd function, okay, an odd function, it's going to have origin symmetry. An odd function has origin symmetry. All right, remember what origin symmetry looks like. We're looking at opposite quadrants, and they want to look similar. You want to be able to fold something over the x-axis and over the y-axis and see if it matches up. All right, so we've got some pictures down below. I'm going to draw 3 more just because I can. I'm going to draw this and this. And this. All right, let's look at these six graphs. Show me with your fingers. On that V up there in the corner, show me a 2 if you think it's even. Show me a 3 if you think it's odd. Show me a bird if you think it's neither. Okay, so even, odd, or neither. On this first absolute value graph right here, show me with your fingers. Is that thing even, odd, or neither? Even. What type of symmetry does it have? Y-axis. You could take that thing and fold it right over that line. It's going to be an even function. Okay. My second graph here, this reciprocal graph. Show me with your fingers. 2 for even, 3 for odd, bird for neither. That thing is odd. It is an odd function. If I were to take this line right here, I could flip it up, and then I could flip it over, and it would match up. Okay. Opposite quadrants look opposites. That's an odd function. Origin symmetry. Okay. This next one, that is a cosine curve. Show me with your fingers. 2 for even, 3 for odd, 4 for neither, or bird for neither. That's even. It has x-axis symmetry. Or y-axis symmetry, sorry. You can fold that right over the line. That cool graph that I drew right there. Show me the fingers. 2 for even, 3 for odd, bird for neither. Make those wings flat. Make them flat. But I definitely can't go across that line. I can't fold it over. Okay. This quadrant right here. Sorry. This quadrant right here definitely does not look like this quadrant right here. That one doesn't look like, it is not odd. Opposite quadrants have to look similar for it to be odd. That is not true. Okay. This graph, even though I drew it poorly, imagine I could draw something good. 2 for even, 3 for odd, 4 for, or bird for neither. I'm already off. That's even. At least as even as I can make it on the fly. I tried. Last one. That's a cubic function. X cubed. 2 for even, 3 for odd, bird for neither. We got some odds in there. Okay. Opposite quadrants look opposite. I could take that and flip it up and then flip it over. It would match up. Visually, do we understand the differences between those graphs? We've got an even function has y-axis symmetry. We've got an odd function has origin symmetry. Why do we not have a cool word to have x-axis symmetry? Talk with your neighbor. Why don't we have a cool function word to describe x-axis symmetry? Why don't we have a cool word for x-axis symmetry? Wouldn't be a function. If it has x-axis symmetry, it's going to fail the vertical line test. So we don't have a cool function word for it. We got even functions, we got odd functions. X-axis symmetry doesn't have a function, so it doesn't match. Okay. We just did it graphically. Now we're going to do it algebraically. So by just looking at these equations down below, we're going to be able to determine if something is a function or what type of symmetry that function has. Okay, to check for even, okay, we are going to decide if f of x is equal to f of negative x. If this is true, if f of x equals f of negative x, then it is an even function. And I'll explain what that means here in a second. Okay, if f of x is equal to f of negative x, it means we're going to plug in a negative x where x is. We're going to do some simplifying and see if they're the same. If it is, it's even. Okay, to check to see if something is odd, we are going to determine is f of x equal to negative f of negative x. So to check if it's even, we flip the x value. We make it negative. Okay. To check to see if something's odd, we're really switching both. We're switching the x and the y. It gets a little funky, but that will determine if something's odd. Okay. If you can remember that, you should be fine here. Let's try it. Determine algebraically whether these functions are even, odd, or neither. Number 1 says negative 3x squared plus 4. So the first thing we're going to do is check if it's even. That's the easiest way to do it. Okay, so we're going to find f of negative x. We are going to make our x values negative. Because think about it. If it's even, this side of the graph where it's positive x values is going to be the same as that side of the graph where it has negative x values. Okay, those two sides need to be equal. The negative x's and the positive x's need to be equal. That's why we're doing this. Okay, so I plugged in a negative x there, and I don't have any other negative x's to plug in. Then I'm going to simplify. What happens if I take a negative x and I square it? It's positive. So this is negative 3. Negative x squared really is the exact same thing as positive x squared. Because if I take a negative x times a negative x, it'd get me positive x squared. That's all only simplifying I can do. I took the negative x, I squared it. Is this thing right here, this is f of negative x, is that the same thing as f of x? Yeah, it's the same. That is an even function. Because when I plugged in a negative x, it was the same, it's even. Okay, if I were to go right here and I were to type in that equation that we just had, negative 3x squared plus 4, cool, it's even, just like we thought it was. If you had a graphing calculator, do f of negative x and figure it out that way, but then check it because you're smart kids. Use your resources. Letter B. And if it's even, I don't have to check odd because it can only be one or the other. Can't have both. 2x cubed minus 4x. So first thing I'm going to do is check to see if it's even. If I take negative x and I cube it, what's it going to be? Yeah, it's going to be negative x cubed. So I'm going to throw that negative out in front, but it's really negative 2x cubed, right? It's x negative x cubed times 2, so it's negative 2x cubed. I got a negative 4 times a negative x. That's 4x. Okay, this is what f of negative x is. Is this the same as this? No, it's not. Sad face. Not even. Doesn't mean it's not anything. It's not even. Okay, then I'm going to check to see if it's odd. Well, we already found f of negative x. If I want to check to see if it's odd, I'm basically seeing is it exactly opposite. So I'm going to now make everything the opposite sign. Think about what we're doing. We changed the x value by making the x negative, and then we're changing the y value by flipping the other. If we want origin symmetry, you have to flip over the x and the y axis. That's why we're doing both here. Okay. So I'm going to basically multiply everything by a negative. So everything in this problem, I'm going to change the signs. Positive 2x cubed, negative 4x. Is this thing right here, when I changed both things, the same as what I started with? Are those exactly the same? Yay. It's odd. It has origin symmetry. Again, so you don't think it's magic. Let's type it in. Is it 2x cubed? And then minus 4x or plus 4x? Minus 4x. Is that thing odd? Yep. We're good. We're 2 for 2. It's not just magic. We're doing real math. Let's go to the last one. Woo, a big one. All right, so first thing we're going to do is determine if it's even. Plug in a negative x. So 2 negative x cubed minus 3 times negative x squared minus 4 times negative x plus 4. A lot of stuff going on there. We're going to simplify. Okay, so this thing right here, it's a negative x cubed, so it's going to be negative 2x cubed. It's going to stay negative because I cubed it. What about the next one? I'm taking negative x squared. Negative x squared go positive, but it's times negative 3, so it's negative 3x squared. Negative 4 times negative x, so that's going to be a positive 4x and a plus 4. That is f of negative x. That's what we found so far. Is this thing that we just found, is this the same that we started with? No, so it's not even. I changed the x values, it's not even. The left and the right side are not the same. So then we're going to check to see if it has origin symmetry by flipping everything. Now I'm going to find negative f of negative x. I'm going to change all the signs. So it's going to go positive 2x cubed, positive 3x squared, negative 4x, and a negative 4. I just went down the line and changed all my signs. Is this thing that I have here the same that I started with? No. So it's not even, it's not odd. So what type of symmetry? Neither. It's got neither type of symmetry. Again, what do we have? 2x cubed. What was my next part? Minus 3x squared. And then what? Minus 4x plus 4. Yeah, it looks kind of odd, but it's not odd. It's not balanced the way it should be. This quadrant right here does not look the same as that top one. Okay, let me show you a quick shortcut. This only works for polynomials. It doesn't work for everything. But for this polynomial right here, okay, negative 3x squared, my exponent is a 2. That's an even exponent. Okay, we're going to kind of cheat here, but 4x to the 0, because there isn't one. And we're going to cheat again and say that 0 is considered an even number, even though 0 is nothing. Both exponents are even, so the function is even. And my next one, what are my two exponents here? 3 and 1. Are both those odd? So the function is odd. This last one, I got a 3, I got a mix. As soon as you have a mix, it's neither. I got a 3, a 2, a 1, and a 0. Okay, so I got 2 evens and 2 odds. It's neither. Okay, you can do that all day long with polynomials, not anything else. So if I created a function, somebody give me a number. What's my power going to be? Somebody tell me a power. 7. Great choice. Okay, right now it's just 7x to the 7th power. I only have an odd exponent. It's odd. Okay, I'm going to pick another one. Plus 3x. Give me another odd exponent. 3. Is it still odd? Cool. Now give me an even exponent. 2. Is it odd anymore? No, now it's neither. Okay, see how it's not in this quadrant? That's all it is. Okay, that only works with polynomials, though. That's just a list of things with exponents. Okay, so that's not too bad. Let's go down below. Now we get into a little bit different. So the rule I just told you about exponents doesn't apply here because this is not a polynomial. Okay, it's a rational function because I've got a fraction. All right, so first thing I'm going to do is find g of negative x. I'm going to make every x value negative. Okay, I'm going to make every x value negative. So on top, it's still going to be negative x. On bottom, it's going to be a positive x squared minus 1. Is this function even? No, because this right here is not the same as that right there. So not even. Then you got to be careful here. Here's the number one mistake you're going to make today. Now I'm going to find negative g of negative x. I'm going to multiply by a negative 1. Okay? And some of you asked me this question the other day. It was a good question. It was like the first day of homework. Okay, negative g of negative x. What do you think here? Is this function, take a second and think about what you would do. I wouldn't write anything down because you're probably going to write it down wrong. Thumbs up if you think this function is odd. Thumbs down if you think this function is not odd. Thumbs up if you think it's odd. Thumbs down if you think it's not odd. It is odd. Let me do you a quick reminder here. Okay. If I took 3 times negative 1, what are you going to get? Negative 3. right? If I multiplied 3 by, it would get me negative 3. So if I wrote it as 3 over 1 times 1 over 1, it should also get me negative 3 if I multiply by a negative. But if you multiply both the top and bottom by a negative, then I get negative 3 over negative 1, which would be positive. If you are multiplying a fraction by a negative, you do not multiply the numerator and the denominator, because you're not multiplying by a negative if you multiply both. You just want to multiply one of the parts by a negative. That's going to get me a negative 3 like I'd like. Does that make sense what I'm describing there? That's a weird concept. It doesn't make sense at first glance. Okay, so what that means is I'm going to just multiply the top by a negative 1. That is what negative g of negative x is. So is this function odd? Yeah, it's odd. Okay, because when I multiply just the top by a negative, we are good. Okay, let's just look at it so you know what it looks like. X over x squared minus 1. Woo! That's a cool one. That's odd. See it? Let's do another one. Try your next one on your own. See if you can figure out what E is without me helping you. Show me with your fingers. 2 if you think it's even. 3 if you think it's odd. Bird if you think it's neither. 2 for even, 3 for odd, bird for neither. I'm seeing odds and neithers. Let's decide which one it is, odd or neither. Okay. You guys didn't say it was even, so let's make sure that that's true. So f of negative x. So everywhere there's an x, I'm going to make it a negative x, even inside the absolute values. Okay. So this is negative x still. What happens if I take a absolute value of negative x? It's going to be positive x. Okay. That's what f of negative x is. Is that the same that I started with? No. Okay, so then I'm going to find negative f of negative x, or in other words, multiply everything by negative. If I multiply negative x by a negative, it'd be a positive x. And then if I multiply this by a negative, it would be minus absolute value of x. Is that the same thing I started with? So what type of symmetry? It's neither. Okay, just so you see it, let's graph it. X plus the absolute value of x. There's your graph. Definitely not even, definitely not odd. It's neither. All right. Flip that paper over to the backside. Well, you'll have some more practice with that tonight, so you shouldn't be awful with it. We'll start tomorrow's class by going over any questions you have from homework, so you should be fine. Backside, okay? Look at this thing. Average rate of change. Average rate of change is the same thing as delta y divided by delta x, or in other words, f of x minus f of c all over x minus c. It's a big, scary thing, okay? Anybody recognize what that is right there? That is slope. That's all it is. It is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When you hear me ask you the phrase, what is the average rate of change in your brain? As soon as you hear average rate of change, you are thinking slope. Average rate of change means slope. That's it. Okay, that's the only thing I need you to think about. Average rate of change means slope. Today, technically, we are finding the slope of the secant line. A secant line is a fancy word that means a straight line between 2 points on a graph. Okay, so this is a cool curvy line. Okay, it's a curvy line. I can't find the slope of curves. Okay, that's what we do in calculus. We don't know how to do that yet. But if I wanted to find the average slope between those two blue dots, you would draw a line and find the slope of that secant line. The secant line is a line that crosses your graph in 2 points. All right, so to do that, that's average rate of change, secant line, all it means is slope. Find the average rate of change, the slope, from 1 f of 1 to 3 f of 3 on that graph right there. All right, so this is a parabola. You are finding the slope between two dots. That's basically what we're trying to describe here. That's what average rate of change means. I asked this question earlier and we struggled. If I'm asking you to find the slope of a line, okay, what do you need in order to do slope? Thank you. 2 points. If I'm asking you average rate of change, ooh, I see average rate of change, I think slope. What do I need in order to find slope? 2 points. It's worded a little bit strange, but what do you think my x values are going to be here? 1 and 3. How am I going to find my y values? Plug them in. 1 squared is 1, minus 2 would be negative 1. I plug in 3. 3 squared is 9, minus 6 would be 3. There's my 2 points. Then all I'm doing is finding slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's 3 minus a negative. I get 4 on top. 3 minus 1 gets me 2. The average rate of change, the average slope of that line on that parabola is 2. That's what we just found out. Questions on how I found it? It's easy. Okay, let's talk about this quickly. Write the equation of the secant line. If I'm ever asking you to write the equation of a line, you are going to use point slope formula. Okay, point slope formula. That is the only way you want to do it. I know there are other ways of doing it. Don't do any other way. Use point slope formula. It's the same thing we'll do in calculus. It makes your life a lot easier. Okay, this is point slope formula. It sounds big and scary. It is not. You need 2 things in order to find, or in order to write an equation of a line using point slope formula. What 2 things do you need to make point slope formula? Genius. A point and a slope. Here's how you should set this thing up. Just like that. Y minus whatever my y value is. X minus whatever my x value is. I'm going to plug in my slope. I know what my slope is. My slope is 2. Which point do you want to use? Doesn't matter. I would pick the 3, 3 one because you can't screw it up. You put the x with the x. You put the y with the y. Oh, see, I just screwed it up. I can't even make a 3. It's not a good sign. Boom. This is the equation of the line. All right, let me show you visually what we just did. So our equation was 2x squared. What? 2x squared minus no, it was x squared minus 2x, right? X squared minus 2x. And then we wrote the equation of the line. It was y minus 3. Don't solve even. I don't care. Y minus 3 equals 2 times x minus 3. That's the secant line. We went through the points 1, negative 1, and 3, 3. We wrote the equation on the line that gave us that slope. That's the secant line that we just created there. Makes sense visually what we did?